This is a video for section 1.3 for Math 120. I'm going to start with a quick review of what we did in class with piecewise and Pascal's triangles, actually in previous videos also. So to do piecewise functions in the calculator, in y1 we're going to put, and when I ask you this, I'll ask you to put in y1 and then sketch a graph. So in y1, for this function we would put parentheses x minus 2, that's the first piece, parentheses x is less than or equal to negative 3. And remember, this is under second math to get this symbol, which is the test menu. And we also want to do these other two, so we'll add these to the screen. So this will be 3 in parentheses. Now this has a double-sided. I haven't done this before. This is the first time, so you want to take good notes here. This will be x is greater than negative 3. So I'm starting with x. I'm going greater than negative 3. And the and can be found in second test, and you'll have to go over to logic. So looking at this, second test, see where logic is? And the word and is there. So you'll have to get that out of that menu. So you want to study that. You'll need it for the test. And then second, test, math, which is test, logic. And we also need that x is less than or equal to 2. And then the last piece, we'll need negative 2x plus 4. X is greater than 2. And close that parentheses. So in my y equals, I'll put this formula exactly as I have it here. So you'll need to write it down so I can see what you tried to put in your y equals. And we put that in, if you'll do a zoom 6, that's a standard grid, it'll draw a graph for you. And it should draw these 3 pieces exactly as they are there. The first one I can see is in mx plus b form, so that's a line. This is a horizontal line. The y equals 3 is horizontal, so I should expect to see a horizontal line. And this one also is in mx plus b form, so that's a line. Now when I go to graph these, I'll need to put open and closed circles. Remember that a less than or equal to means I'm going to include that point on that piece, so I need a closed circle. A less than says I'm not going to include that on that piece, so I'll need an open circle. I'm going to draw mine a little precisely here, but it's not really that necessary. I can see the important pieces are that I got the 3, and down here it's 1, 2, 3, 4, 5. See, if I put in negative 3 here, that'll be negative 5. So I know for sure I need negative 5. I don't need to label a whole bunch of tick marks. They don't have to be that evenly spaced. I'm not real picky. But you should be able to put some tick marks on there to give me an idea of what I'm looking at. Negative 3 is important because it's the end of the piece. And then 2 will also be important. So I'll put 2 in because that's the end of the piece. Now I can get the points that these pieces are on, or I could trace and find them. So for just a second, I'm going to get the points that the pieces are on by putting these in. Negative 3 minus 2 is going to be negative 5. So at negative 3, I'm down at negative 5. I have a closed circle. And I can see on my graph it looks like that. Doesn't have to be precise. Close enough is good enough. From negative 3 to 2, I have a horizontal line. So at this end piece, it's less than, got an open circle. At this end of this piece, it's less than or equal to, so I have a closed circle. So that's what I'm expecting to see on the test. And then for the line here, I'm putting 2 in. I get negative 4 plus 4. I should be at 0. Hey, that looks like it's at 0. It's a greater than, so it means an open circle. And I can just draw my line. So that would give you full points for that kind of problem. Now we did Pascal's in class the other day. So I know I'm going to need Pascal's triangle with 7 on it. So I'm going to get started. You should look at the notes from the other day. I won't review this one again because you already have those notes. I'm going to have to go down to, this is the 5th power, so I need to go to the 7th. 1, 5, 10, 10, 5, 1. 1, 6. Remember, we're adding 15, 20, 15, 6, 1, 1. I'm adding 7, 21. 15 and 20 is 35. 35, 15 and 6 are 21. 7 and 1. Now in class, when I did this, we did it in 3 rows. You could do it all at one time. Some of you are just that good at it. So if you can do it in all one time, then go ahead. But in 3 rows, I know I'm going to need the coefficients from Pascal's triangle, which is what this gives me. This is a binomial. Pascal's gives me the binomial coefficients. Sometimes I ask that as a bonus question, so you might want to study that. So we have 1, 7, 21, 35, 35, 21, 7, and 1. So I'm going to put parentheses for each of the powers here. They're both plus, so I'm not going to have to worry about powers. About signs for the coefficients. Everything's going to be positive. And it could be either way on the test, positive or negative. So in each of these, I'm going to put a 5y, and each of these I'll put a 2z. Just do it like machinery. I usually don't go as high as a 7th power. On the test, it's usually 5 or 6. Sometimes 4. So I just put all these in. And then I have to put the powers in. Remember that the 5y's are going to start with a 7 and decrease in power. Right there, I made a mistake. 2z. Oftentimes I'll do the first row because it's 5y all across, and do the second row, which would be 2z all the way across. So I'm doing 7, 6, 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7. And I'll pause, and you should pause too, and see if you can figure these out, and we'll test to see if we end up with the same answers. Hopefully I'll get it right. So I ended up with these coefficients. So in here, for this last one, I did 2 to the 7th. For the one before, I did 7 times 5 to the 1st times 2 to the 6th. That's what that says. The one before that was 21 times 25, which is 5 squared, times 2 to the 5th, which is 32. So that's where I'm getting these coefficients. And notice the powers are coming down for y and going up for z. So be sure to check this. If you find an error, it's bonus points for the test. So make sure you email me right away if you find an error. We went over shifts of graphs in class, so be sure to view that Zoom video if you haven't already, or go back and review it if you've kind of forgotten and didn't quite take your notes as well as they should have been. So each of these questions in number 2 on 1.3, you're going to have to tell what the shift did. So all of these should be straightforward to you. Let's work an example that's not quite as straightforward. On the test, it'll look like this. Explain how each graph is obtained from y equals f of x. So we want to know, we can see there's 1, 2, 3, 4 things that have been adjusted here. So the negative is a vertical reflection. And you could put BREF, and that'd be fine with me. The 3 is a vertical stretch 3. The 2 in here, if it's in with the x, you're going to do the opposite pretty much. But the 2 in here is going to tell me that I have a horizontal shrink of 1/2. And then plus 7 means I went up 7. That's what I'll expect to see on your test. And of course, you could have written the word up there. On this next one, 1/3 is a vertical shrink of 1/3. Now in here it's a little bit tricky because it's negative 4x plus 8. If I set this equal to 0, that's actually going to give me my shift horizontally. So I'm going to do a horizontal shrink, a horizontal, let's see which way it is going to be. It's going to horizontal right. And it's where negative 4x plus 8 is equal to 0, which gives me that x is equal to 2. Horizontal right 2 is what this will do. And if you put something in your calculator with like an x squared, put in negative 4x plus 8 in the parentheses, you'll see that this actually does shift it to the right too. Now negative 4, the negative means I have a horizontal reflection if it's front of the x. And the 4 means I have a horizontal shrink of 1/4. So each piece here, every time you see a negative, it's going to tell you some piece of information in front of the x, just in front of the x here, will be horizontal reflection. Now, we had two separate things on our sheet that said we could do shift left or right or up or down or the horizontal shrinks and compressions, but all those on our sheet had to do with doing one at a time. So this has a bunch of them thrown together here. So what you really want for the horizontal shift left or right is to set whatever's in the parentheses equal to 0, and that'll tell you the horizontal shift left or right. H goes over 2. And then the -2, of course, is down 2. So on 1.3, number 3, they're giving you a graph. I won't do these on the test, but you can get them correct on the homework. Giving you a graph to be able to do shifts and stretches and reflections and things like that. So this graph here, this says compress it, shrink it by 1/2 horizontally. So that means it's like I'm just going to push it. It's called a compression. I'm just going to push it and it'll be half the size. So each of these points are going to go to the halfway point. This will go to the halfway point, which should be there. And I can see it looks exactly like this with a halfway point. This is going to half. So if you think about these corners as elbows and where they go if you shrink them in, that's what you would get. Part C is a negative reflection, so it's taking this thing and it's flipping across the y-axis. Negative reflection. So it should be exactly what we had above, only it's flipped across. So you might refer back to your original graph. Note in number 4 that they have not asked you to simplify, so you really could put in just a difference in the x's here. This is going to be twice as tall. That's a vertical stretch, and those are pretty easy to put in. And then this is shifting over. I can see it shifting over to the middle of it was 1, and now it's shifting over to 6. So there's your hint. It was still 1 apart from there, so it hasn't shifted to be, it hasn't done a stretch or anything. But all the x values are going to shift over to 1 is going to 6, 2 would go to 7, 0 would go to 5. So there's your hint on that one. I won't have you do the trigonometric functions on this first test without a calculator. So you could put this in your calculator, make sure it's in radian mode. Let me show you how to do that. So make sure you're in radian mode, go to mode, and it should say radian. Radian mode. So if I was going to graph this, I'd put the sine of 1 divided by 6 x, which is 1 divided by 6 times x, order of operation. Let me just check and make sure that's the right one. Sine of 1 divided by 9 is what I'm doing. So 1 divided by 6 would look a little different. I can see they're wanting up to 2 pi here. Maybe as much as, what would be 5/2 pi. So they'd want 5/2 pi to negative 5/2 pi to 5/2 pi. But I'm going to do a zoom trig to see what this looks like. Zoom trig is 7. And it'll set it up so that I can see this a little bit better maybe. Now it's not showing me enough, so I'd like to see a little bit more than this, but I can see that it's really stretched out, which is what I expected because 1/9 would be a really strong horizontal stretch. So I could try zoom fit. That's zoom 0. Let's see if that works a little better. But it often doesn't. All it did was stretch it so that I'm just seeing where the ones are. So if I wanted to see this a little better, I'd have to go to my window once this stops. Go to my window. And I'm going to set this, I set it, what was it, negative 2.5 pi, alpha pi. Oops, that's just second pi. And then 2.5 pi. Second pi. And I'll go from maybe negative 2 to 2 on the y, negative 2 to 2. Just a heads up on how you can quickly get these done in your calculator. I'm going to hit graph now. If you do zoom anything at all, it's going to change that. So now I can see that it stretched it way on out. And what I had as my original graph the 1/9 x is going to be stretched way on out. So whatever this value is, these aren't stretched very far and these aren't stretched very far. So that kind of gives you a hint as what you're looking for in those answers. Now I will have you do some graphs on the first test, and you can pick up your calculator and do it, but I recommend highly that you think about what the graph's supposed to look like before you pick up your calculator, because it'll make it a little easier. I just did a zoom trig, so I'd have to do a zoom standard to get it back to see what this looks like. Now looking at this, I can see 3 minus x is, this is square root graph. It's going to have to go reflection on the y, a reflection on the x. There's a reflection on the y, a reflection on the x. So basically, if I put in this, what makes this 0, I'll be at positive 3. 1, 2, 3. And then it's going to go up 1, up 1. So what makes this 0, and whatever is there, is going to take the original graph, which, if you remember, I showed you these in class the other day. It looks like this. There's a 1, 1 there, and a 0, 1. So I'm taking that original graph, and I'm doing stretches and shrinks or whatever I've got in here to that original graph. Now this tells me that I'm going to go down 2, 1, 2, and this is going to go over negative 1. So over negative 1. So it would have originally gone this way. So the graph goes like this, but it's going to go this way. So I can get that second point and put that in, and end up with a graph that looks like that. So that caught the up 1, the over 3, the reflected in the x, and the reflected in the y. The reflected in the y was that down, the negative 2. So down 2 from my original point. Doing the same with this one, I start with an x cubed graph. It looks like this. It's easier if I start from the middle. These are the 3 points I'm interested in. Oftentimes, if you give me more information when you're doing the graph, like where those 3 points are, the more I'll be able to give you in partial credit. So this is going over 2 to the left, and it's going to go down 3. So there's where that 0 went. Whatever makes this 0 and whatever the up or down is. So that's where that 0 is. It's reflected, so it's upside down. So this point's going to go up. It's going to be reflected, but it's not stretched anywhere. So reflected, so it'll be like here and there. And like I said, you can pick up your calculator and do this. But I recommend that you challenge yourself to think about what it's going to look like before you put it into your calculator. And hopefully I did that right. So if I didn't, send me an email. I'll give you bonus points. Number 6 is combinations of functions. So they're just asking you to add these two together. And it's just as easy as writing this x cubed plus 5x squared, Control C, Control V, plus 7x squared minus 2, Control C, Control V. And I'm going to have to put in some exponents. 3. So I just changed it a little bit, and I could have just started it from the beginning and typed it. This will be to the second, and this will be to the second. Notice that it does not ask you to simplify these, so you can basically just type what I've written here. Now once I have this, I can copy and paste this. It is what I need. But I need parentheses here, because the second one I'm subtracting. So I need to put a subtraction of that, or change the signs. I could have just changed the signs and that would have been fine. Okay, and the next one you'd want to do the same thing, copy and paste. Only I'm going to put parentheses in to multiply. These are pretty easy. I won't do any more of these on this exercise, but you get the idea. Pretty easy to get these functions right. Now, if you start with a polynomial, polynomials always have their domains of all reals. So unless you put something in the denominator that's 0 or you have an even radical, you're going to have all reals. So I started with two nice functions, polynomials, continuous, everything's nice about them, all reals. And this funny looking R, it's a 2-line R with the rest of it written, is what that R, all reals would be. I can combine them any way I want to and end up with all reals as their domain. But if I divide by this, whatever makes this 7x squared minus 2 equal to 0 would be an exception or a restriction. So you can't have that in the denominator. But I don't think they ask us. Yep, they do right here. They ask us, and you can see you can't have x is equal to 2/7. So you set that equal to 0. We'll do a couple more of these examples. In the next one, they're going to be doing compositions, so we'll also go over compositions and the domains and range for those. So in the test, I'll ask you the combinations of functions like this: f plus g, f minus g, f of g, f over g, g over f, things like these functions, and the compositions. So let f of x be x cubed. So I can see the domain here is all reals because this is a polynomial. So this is all reals, and I'll write it like that. You could write it in interval notation, but that's really not necessary. Some of you are thinking negative infinity to infinity. I usually don't write that because it's more than I need to write. Here, x has to be greater than or equal to 0 in order for this to be right. So x is greater than or equal to 0, or I could have written 0 to infinity. Either one of those. So there's an or in there. And we'll go over more restricted domains in just a minute. So f plus g, I would just write x cubed plus square root of x. F minus g is x cubed minus square root of x. F times g is x cubed times the square root of x. These are very straightforward. And f over g is x cubed over the square root of x. G over f is x cubed, well actually square root of x over x cubed. So let's talk about the domains here. So the domain of this one, and you could write domain of f plus g, but I'm writing it right beside it, so I don't need to write all that. It's going to be the intersection of these two domains. So what they both share here is what the domain of their composition, well, their combination is going to be. These are compositions, these are combinations. So the domain of the combination here is going to be 0 to infinity. The same will be true here, 0 to infinity. And here, I can no longer put negative numbers in here and get real numbers out. And we're only interested in Calculus 1 in real numbers. We aren't interested in the imaginary numbers. Now, before I could use 0, but now I have 0 in the denominator, so my domain is going to change a little bit here. It's going to be 0 to infinity without the 0 included, because you can't have 0 in the denominator. The same is true here, 0 to infinity. So I needed the intersection of these two sets, which ends up being this, the 0 to infinity. It's included if the 0 is not in the denominator. It is not included if the 0 is in the denominator. Now f over g is a composition, so that means that I'm going to put, well, it says actually f of g of x. That's what the notation means, right? The composition notation. So that means I'm going to go to my f equation and put g of x in it. My f equation says I have something here, x cubed, but instead of putting x, they want me to put g of x. Now I don't require that you write this like this. You can skip this step. You don't have to write this step either. But you want to be thinking this so that you get the answer correct. So this is the square root of x cubed, which gives me x to the 3/2 power. Or I could leave it like that. G of f is g of f of x. So that says go to the g equation. Everywhere you see an x, put an f of x. So that means the square root of f of x, which is the square root of x cubed, which gives me the same function. But if I'm writing it just like this without simplifying it, you can see these two are slightly different. This is f of x with g of x on the inside, and this is g of x with f of x on the inside. Now the domains of these have to do with the domain of the inside, which was, in this case, the square root of x. So I have to use that domain and any further restrictions I might gain. So both of these have a domain of 0 to infinity. I usually don't ask the domains of these on the test, but you should be able to compose them without any problem. So let's talk a little bit more about restricted domains. I'm going to cover this up for a second so we can talk about it and think about it. So for any polynomial, I already said this, the domain is all reals. And that's x to the 5th, x to the 7th, x to the 3rd. But you can't have 1 over x, because then you have a problem, because then you have denominators. So restricted domains occur basically in 2 places for us. Some of the trig functions have restricted domains too, but we're not going to cover those. We'll assume you've done those before, and we won't go back over them. Denominators can't be 0. And under even radicals, you can't have negative values. So those 2 things. So for instance, if I have 1 over x, that means x can't be 0, so the domain would be all reals, x is not equal to 0. And we'd write it like this. All reals, x is not equal to 0. Or we could write negative infinity to 0, parentheses, union. The union symbol comes up when you're working through the domains here on WebAssign, and you can get that from the set notation on the side. I'll show you that in a second. This one, x squared minus 16, can't be equal to 0. So then I have to solve this, and I get x squared can't be negative 4 or 4. So that can't be 0, so that factors, and I end up with negative 4 and 4, so that's what I have. Or I could write it like this, negative infinity to negative 4 union, negative 4 to 4 union, 4 to infinity. Parentheses everywhere, because the endpoints of all these intervals cannot be included. Note that infinity and negative infinity always have to have parentheses there. And these have to be in numerical order. So negative infinity comes before negative 4, negative 4 comes before 4, and 4 comes before infinity. You can't write these backwards or they'll be incorrect. So be careful of that. So the other one, the other restriction, first restriction, no zeros in the denominator. Second restriction, you can't have negatives under even radicals. So cube root of 3, I can do. Cube root of x, rather, I can do. It's all reals. Here, square root of x has to be greater than or equal to 0. Square root of 3 minus x has to be greater than or equal to 0. On a number line, it looks like this, and if you graph this, square root of x, you'd see that from 0 on, you can actually see the graph. If you graph this one, from 3 back, you can see the graph. So you can kind of check when you've done this to find the domains. This will be on the test, be sure to study it. Number 7 has to do with composition of functions and their domains. We just covered some decomposition, so you have an idea of what that's supposed to look like. But f of g says that I'm taking my f function and putting g in there, and g is cosine of x. So this would be 5 minus 2 cosine x. Whenever you compose 2 functions that the domain for each of them is all reals, you're going to end up with a function that's all reals. So 5 minus 2x is a line. It's the nicest thing you can draw just about. And sine and cosine are both nice trig functions, so both of those have domains that are all reals. So composing these, either f of g or g of f is going to give you a domain of all reals. This does not say to simplify, so basically you can do 5 minus 2 and put cosine in. And here you're going to do cosine and put the 5 minus 2x in. F of f says I'm putting f inside of f. Again, it does not say simplify. You can spend time simplify if you want to, but it doesn't say to. Now, number 8 here has f of g of h, which means I'm going to take h and put it into g and then put that into f. And it does not say that I have to simplify again. So you may have to, but most likely you don't unless it says so. This one they're asking you to do this backwards. So they're trying to have you express a function in the form f of g, use non-identity functions for f and g. So f of g says I put g inside. Notice the thing that's repeated here. See the g? So everywhere I have a cube root of x, I could put an x and I get my f and g. They already have the braces. They just want a comma. So I might put for f here x divided by 7 plus x. And for g I'd put the cube root of x. So they're asking you to do the same kind of thing for 10. And 11. So just take your time doing these. Start with the thing that seems the most strange, replace that with an x, and then go with the next thing that seems strange. You can go straight across. These are not unique, but they want you to use non-identity functions for f, g, and h, so that means don't use f of x equals x. So number 12, use the table to evaluate each expression. And on these expressions, they've got g of 1. Well, I need to find g of 1. That would be 3. And now I need f of 3. F of 3 would be 1. These are really easy. It's just a matter of getting your mind lined up. G of f of 3 down here, that means f of 3, which would be 1, and then g of 1, which would be 3. So just take your time on them. They're very simple, but it takes a little while to get your mind aligned. On number 13, instead of giving you a table, they've given you graphs. So you can do g of 2. G is up here. G of 2 would be, it looks like 5. And then they want you to do f of 5. 1, 2, 3, 4, 5 would be that. So that looks like f of 5 is 4. Just take your time on it. These are really easy. If they're not easy to you, make sure you catch me in my office hours or make an appointment. Distance equals rate times time is a concept that was taught to you in Algebra 1, but you might have forgotten it, so I just restated it. So if we're expressing the radius of the circle as a function of time, well, it's how fast it's going out times the speed that it's going, which is 70. And it says in terms of centimeters, it doesn't, so we'll just do 70t. That'll give me my radius. Now, if the area of the circle is a function of the radius, find a of the radius. Remember, the area of a circle is pi r squared. So touching here, you can get symbols. The pi is there, the infinity is there. You might have seen this already because they alerted you to the infinity. So you're going to need pi times whatever you put in for the radius squared. For number 15, they just want you to take this function and do shifts and stretches of it. So this one isn't going to shift it. T equals 0. It's going to be 0 until then. And then after 0, they want it to immediately go to 130 volts. So here, my function is going to be 130 times what it originally was. And here's the original. So they just want this in terms of h of t. They also want this one in terms of ht. So if you're switching on time t equals 7, that means I've got to shift to the right of 7 seconds. Then it's going to be 240 instead of 1. So you're just doing the shift and the stretch that's necessary for this function. So a hint for number 16 is that I want to put f inside of a g function, and it needs to end up being h. I know definitely I have to multiply it by 5, and then there's probably a shift up or down that you're going to have to add to that in order to get the correct functions for this. The rest of these are, think about it, see if you can find something that will make it false. If not, then you'll assume that it's true. A bare denial is what that's called.